see terminology here, especially like once we get to these sections. I'm going to kind of explain things a little differently and try to make it as easy as possible. But you do need to know what an even function is and what an odd function is, and how you test to see which one of these two, if it is either of these two, it is. Okay, it's possible that it's not even and it's not odd. But an even function, and I actually would prefer to write it this way, is when you plug in negative x and you get what you started with originally. In other words, plugging in negative x doesn't change the function at all. It's still the same function. That's what it means for it to be even. Okay? And odd, again, I'd like this to be, actually this is the correct order. When you plug in negative x, you get the opposite of the original function. Okay? And that's a good way to think about what this stuff is, rather than like negatives and where all the little minus signs go. So just think, if I plug in a negative x, I get the original function. Great, that's even. If I plug in negative x and actually it's the opposite of the original function, then it's odd. Okay, and if it's neither of these two, then it's not going to be anything. Okay, so here's how that's going to work. So first example, here's the original function. F of x equals negative 3x squared minus 7. It's kind of set up for you to actually test it. So first we're going to figure out f of negative x. So that's going to be negative 3 times negative x squared minus 7. All we're doing is plugging in negative x. Everybody good with that? Okay. And now we just simplify that. So before we start comparing, is this the same thing as I started with, or is it different? We're going to clean it up. So what happens when you square this negative? It turns into positive. So in other words, this is really just x squared again. So we're going to get the same exact thing. You guys see how that matches the original function that we started with? Okay? And so I'm not even going to bother testing negative f of x. Okay? I'm going to say the function is even, and the reason it's even is because f of negative x matches the original function. Does that make sense? Okay. Let's try the next one. So, again, to test to see which one of these two it is, you just plug in negative x. And then you simplify. What happens when you cube a negative? It's just negative now, right? So I'm going to rewrite this as negative 2x cubed. And now a negative times a negative right here is positive x. And so clearly, this does not match the original function, so it's not even. Okay? So now we're going to see, all right, well, what's negative g of x? Well, negative g of x just means the opposite of 2x cubed minus x. And so if you distribute the negative, you are going to get what we got up here. Does that make sense? And so what do we say? This function is odd because f of negative x is the opposite of f of x. Okay, why don't you guys try C real quick. What are we getting? I hear an odd. I hear neither. You think neither too? Okay. It is neither. It almost is odd, but not quite. If you plug in negative x, when you cube the negative, this whole thing turns into negative 3x cubed, but this plus 5 is still going to just stay positive, right? And so when you do the opposite of the original function, it would need to turn into negative 3x cubed and negative 5. Does that make sense? So since these don't match, we're just going to say neither. Okay? Any questions on that? Now, one other thing I want to point out, and it's not a guarantee, but it kind of gives you a hint as to what it might be. What do you think the even and odd refer to? Look at the first one. First one was even, right? Do you notice anything even in there? Exponent. The exponent, yeah. Even exponent. Okay? Because even exponents, whether you plug in a negative or a positive, doesn't matter. You still get the same answer. Does that make sense? What about odd? Odd exponent, what's this exponent? It's a 1, so that's technically odd, right? So that's odd. This one, our initial guess would be that it might be odd, but because of this plus 5 at the end, it doesn't work. Okay? Does that make sense? So at least you should be able to make an educated guess. If you see a square, a fourth, and a sixth power, probably going to be even, right? If you see a bunch of odd exponents, it's probably going to be odd, okay? Unless it doesn't work out. Okay. Yeah.
So if it's like the last one, an odd or even, or if it's an odd and it ends with it getting added by a number, is it either?
Yes. So he just pretty much gave you a way to remember this. If you see odd exponent, and then there's just like a number in there, it's never going to work. It'll be neither. So if you want to write that down, feel free. Good observation. Okay. All right. Let's talk about increasing, decreasing, and constant functions. These are the formal and fancy definitions. We're not going to be worried too much about those. I think you guys already know how to do this just by looking at the picture. Most of this is just knowing how to answer the question the way they want us to answer it. Because if I gave you this picture and I asked you, can you highlight where it's decreasing? Would you be able to do that? Where is it increasing? Probably do that too, right? And is there a part of the graph where it just stays the same, where it's constant? Right? So you guys see those three separate pieces? So you know exactly where, I would hope. You always read it from left to right. So what is this doing here? Decreasing. So I'm going to color code it. This is now increasing. And then this last piece is constant. Okay? So you can see on the graph what's going on. It's just a matter of answering the question the way they want you to answer it. So let's see. What they want us to do is to determine the intervals. And what this means is we're just going to use x values for where it's decreasing and where it's increasing. And they do give us that this point is 0, 0 down here. And at this point is 5, 25. Okay? All right, so looking at the picture, from what to what is this function decreasing? And assume that this does continue. This is just a portion of the graph, right? So from what x value to what x value are we increasing? Fell for it, Ryan. 0 to 5 is the increasing part. Does that make sense? Oh, I made you fall for it because I colored mine incorrectly. Let's fix that. I don't think there's a good way to fix it, is there? Let's try that again. The decreasing is going to be green. Increasing was pink. And constant was blue, so that part's good. Okay, now it matches. That's my bad. Okay, does that make sense where we're getting 0 to 5? Okay. Now decreasing, I think you said it earlier, from negative infinity to what x value? To 0. And now where is it constant? From to, yep. Does that make sense? Okay. Any questions there? Okay, my approach with this class, I mean, there's some stuff in here that's kind of involved, but I try to just make things as simple as possible. And so hopefully that helps and you can remember what to do. If not, always ask questions if you need more clarification. Okay? Okay. Next we have maxima and minima. And before we even talk about those, I'm going to add in something that I call, not I call, but it is called a turning point. Okay, and a turning point is where the graph, I mean, if you want to be really literal, turns around, okay? But I'll say where the graph changes from increasing to decreasing, or vice versa, from decreasing to increasing. Okay? And so again, here's all the fancy definitions. I'm just going to look at the picture. Okay? Let's look at the graph here. And looking at this picture, how many turning points would you say there are? 3. Good. 3 turning points. What about this one down here? Do you guys see where we're getting those? 3 turning points for the first graph, 2 turning points for the second one. Okay? In this, do you guys see that this is a turning point right here? Okay? Would you say that this is a low value or a high value compared to everything else around it? That's a low value. That's what we call a local minimum. So I'm going to actually write in local min. Okay. What do you think this will be up here? That'll be a local max. And then this one over here is also a local min. Okay. So let's see if we can answer the questions now. F has a local maximum at what x value? -1. And what is the value of the function there? 7. Okay. And now for the local mins, those x values are -5 and 2. And the corresponding outputs are 1 and -6. Okay, and I'm going to add one more piece to this. Absolute min. Okay. Absolute means like the absolute lowest point on the graph. We have one of those, right? That's the second minimum that we highlighted over here because there's nothing lower than this point. So if it asks us for the absolute min, I'm going to say that it would be -6. Okay? If they asked us what's the absolute max, even though this 7 value is a local max. Technically, since this graph continues going up, we don't know what that absolute max is. Actually, we would probably guess that it's infinite because it keeps going up. Does that make sense? Okay. Why don't you guys do example 4? Oh, wow. I think we'll be able to get this done today. Okay. So try example 4 real quick. Okay, what's the domain, you guys? Good. Does that make sense to everybody? Okay, this doesn't have arrows, so we assume that we stop when x is -8 and we stop at x equals 2. Okay, so from -8 to 2 is the domain. What x value gives us the largest value? And what is the output there? And so this would be an absolute max. It is the absolute highest point of the graph. And the smallest value is going to be f of, which gives us 8. -8, thank you for the output. And that's an absolute min. Okay? Is this hard, easy? It's just the terminology a lot, right? It's not like it's a lot of work. Okay. Oh, look. We're almost to where we started last semester. So as far as me teaching you new material, we're almost done. Okay. Calculator time. So this test will have a no calculator and a calculator part of the test. Most of it is no calculator, okay? But there will be a portion that's got a calculator part to it, and it's going to be pretty much what we're doing right now, okay? And so this is just going to be a way to show you, if you actually go ahead and graph in the y equals menu and you get a function like this, we're going to go through the process on the calculator where we can actually find these coordinates on the calculator. Once we know what those coordinates are, then we can answer all the questions they ask us, like min, increasing, decreasing, and all that stuff. Okay? So first, if you look at example 6, go ahead and type that function into the y equals menu. And to get the graph, I'd first recommend starting with the standard, like the regular viewing screen. So just to make sure everybody's got the same thing, if you press zoom and then choose option number 6, okay, that's going to make it look like the normal screen there, okay? And so now what we need to do is decide, okay, do I see everything I need to see here? Yeah, it looks like we need to go a little bit further down so I can see what's going on down there, right? So if we go to window now, our graph only goes down to -10. What can I change that to maybe? Okay. I mean, just try something and see if it works, right? This is kind of a trial and error thing. Ooh, almost. Maybe -100. Okay. Looks like we got it. And now if you don't like that everything's kind of squished in the middle, to get an even better picture, you could probably cut these in half. Does that make sense? All right. Now looking at this picture, how many turning points are there? Looks like there's one right here, probably one right up there. It's kind of hard to see. Definitely one there, right? So it looks like we have 3 turning points. And so what I'm going to suggest you do, okay, is over here, just kind of sketch what it looks like. It doesn't have to be very detailed, but just get the general shape of it. So I'm going to draw kind of something that looks like this. Okay, so it doesn't look exactly like it, but turning point, turning point, turning point, and I'm going to kind of label those turning points because we're going to try to find those. If I know what these coordinates are, then you can answer all these questions without too much hassle. Okay, so on the calculator now, and all these steps, by the way, are up here. Like if you forget what I show you right now, you can always go back here and review these steps. But once you have it graphed and you got a good screen to look at, you're going to go to Second, Trace, which gets you to the Calculate menu. Okay, is everybody with me? And then now, you guys can probably guess what we're going to do. This point, is that a local min or a local max? So we're going to go to option number 3, which is minimum. Okay, and then this little cursor pops up. Do you guys see how it's blinking at you? Okay. What it wants you to do when it says left bound is move that so that it's to the left of that turning point. So maybe somewhere over there. And then you hit enter. Okay. Have you guys done this before in your other classes? Some of you are saying no, some of you are saying yes. Okay. And now right bound, so I'm just going to move it to the right of that turning point. And then when it says guess, you don't really have to, I mean, what it wants you to do is kind of move it so that it's close to the turning point, but you don't need to. You can just hit enter. And there it tells us what that location is. Okay? So what I'm going to do is write that down on the piece of paper so I can use it later. And let's just do 2 decimals here. They didn't really tell us how to round, so I'm just going to do 2. And so I'm going to say that the coordinates here are -0.42 and -8.86. Okay. And now let's go ahead and find this one. That looks like it's over here somewhere. Instead of minimum, now we do maximum. And we just need to make sure that we're to the left and to the right of that turning point. And so now over here, it looks like this is 0.47 and -7.06. All right. And now why don't you guys find this last one there?
I keep getting the error message.
Because you got floating around down there. What are you guys getting for the coordinates there? Not quite, but I'm glad that you're a little off. Anybody got anything different? It should be pretty close to what he said, actually.
3.7.
Yeah.
62.2.
Something like that. Okay, so I'm not sure if you were not clearly to the left or to the right when it. We'll try it again, because if you were really close but you didn't actually get far enough left or far enough right, it might give you something close to this value but not the right one. Okay, and it is close, but we do want to be as close as possible. So yeah, let's do 3.70. And to 2 decimals, this is negative 62.75. Okay. Any questions on how we're getting those the coordinates for those locations? All right. Well, turning points. Actually, that's these three. So I'm just going to go see picture. I'm not going to write them down again. Okay, these are the three turning points. Okay. Let's do the increasing and decreasing first. So from where to where is this graph increasing? So that's 1. Does that make sense? And after that, it starts to go down, but then starting at 3.70, it starts to go back up, and it looks like it continues that way forever. So 3.70 to infinity. Okay. What will the decreasing intervals be? Negative infinity to good. And then the second one would be what's this x value? 0.47 to 3.70. Okay. Any questions there? Okay. Minima and Maxima. Minima is just a way of saying minimums. Like if there's more than one, it's plural for minimum. Same with Maxima. All right. And I would just advise you, like on Math Lab, just be careful, read the directions. If they want you to write the actual coordinates, write the actual coordinates for the points. Otherwise, if it just says what's the min, what's the max, you're going to write down the y values. Okay. So increasing, decreasing intervals are always x values. Okay. Minima and maxima, usually those are just the y values of those points. So I'm going to use a different color there. And so minima would be what two y values? And? Okay. Good. So negative 8.86, negative 62.75. Maxima, there's really only one turning point that was a max, and that will have negative 7.06. Okay? Any questions on that? I don't know if you guys are scared, but like last year I remember answering so many questions. Here we're just cruising, so maybe that's a good thing. Although your homework, that worries me. But okay, we're almost done, you guys, I promise. This we're going to skip anyway. So really we only have one more little thing to talk about, and that's average rate of change. The good news is that you already know, if you remember anything about algebra, Do you guys remember how to find the slope between 2 points? Yes. Do you guys remember the formula? Okay, slope. Average rate of change is just another way of asking you to find slope. The reason we call it an average rate of change, you guys, is because, let me just draw a picture here. Let's say I have a parabola that looks something like that. Okay, the slope changes from point to point. Obviously, if we're decreasing on this side of the parabola, we would say the slope is negative. Does that make sense? And then over here on this side, we would say the slope is positive because the graph is starting to go up. Okay, but the problem is it's not like it's always 1. If it was always 1 for the slope, then we get a line, right? So if it changes shape, the slopes change from point to point. And so what we do is find the average rate of change. Okay, and so this is how we write it in function notation. So let's say this point has an x-coordinate of a. Then we would say the y-coordinate is f of a. Because if you don't know the y-coordinate, you just plug in a to get the y value, right? And if this point over here, let's say it has an x-coordinate of b, to find the y value, you would do f of b. Does that make sense? Okay, and so if the points are labeled like this, using the slope formula, do you guys see where this comes from now? Because if you do y2 minus y1, that's where f of b minus f of a comes from in the formula. And then x2 minus x1 is just the b minus the a value. Okay, so this is your average rate of change formula. Okay, I'm going to, because we're pressed for time and we're not going to be so strict about like how you find these answers, I'm just going to suggest that you just find the 2 points and find the slope, because everybody's comfortable doing that, right? If I give you 2 points, you can find the slope. So let's do that. So here we're finding the average rate of change. Here's our function. And this is an x value, so is that. Okay, whenever they say from this value to this value, those are the 2 x values. So I have x1, I have x2. I don't know what y1 is, and I don't know what y2 is, but we can find those, right? What's y1 going to be if x is 2 at that point? Negative 9, yes. Negative 8, when you plug in the 2, minus 1 makes it negative 9. And now if I plug in 5, what's that going to be? Negative 21, correct. Okay. Once you get to this point where you have your 2 coordinates, your 2 points, you can just find the slope like normal. How do you find slope? You do negative 21 minus negative 9, that's the y2 minus the y1, right? Over x2 minus x1, and now you simplify that. Negative 21 plus 9, that's going to be negative 12. 5 minus 2 is 3. What's negative 12 over 3? Negative 4. Okay? Now look, this problem actually, I hope you never have to do again. If I asked you, can you tell me the slope of this? Would you have been able to tell me that it's going to be negative 4? Right? Lines have the same slope everywhere. Okay? The problem is that, you know, eventually when you guys do my math lab and you have a problem like this you actually have to do the points. It's not going to match anything in the problem necessarily. Okay? But if you do see a line, I'm totally cool with you guys connecting the dots there and you saying, oh, slope? You're giving me a line? Well, the slope's always negative 4. I don't have to do all that stuff. Okay? Does that make sense? Okay. That is it for the 3